So in this first problem, you could cross multiply, but let's just kind of stay with the theme that we've been doing, which is to multiply by the LCD, which in this case would be x plus 4 times x minus 3 in either order. And we're going to do that on both sides. So x minus 3 times x plus 4. And of course, on this side, the x minus 3 cancels. On this side, the x plus 4 cancels. And so it works the same as cross multiplying. 6 times x plus 4 equals, let's see, equals 5 times x minus 3. So then you're just going to distribute there. So 6x plus 24 equals 5x minus 15. This is not bad. Subtract 5x. Subtract 24. And you get x equals negative 39. Not a bad idea to plug it in, especially to the denominators, but I think that works in the denominators, so I'm guessing it works overall. On this one, again, multiply everything by the LCD. LCD of this one, if you look at this one as this is really 2 times x, it's really 2x times x plus 1. No, it's really x times 2x plus 1. There we go. So if you look at the LCD here, it would be, well, it's both those things, right? It's x times 2x plus 1. So if you distribute that to everything here, on this side, everything cancels, you just get 1. Let's start with the left-hand side. So the x's would cancel, so this would be 2x plus 1 minus, we distribute that middle term there, so it would be 2x, but just be 2x. The 2x plus 1 would cancel, so minus 2x. And now you're just simplifying this. Well, this is interesting. So we get 2x minus 2x is 1. 1 equals 1. So I guess we say this one is an infinite number of solutions. Or I guess we'd say all reals, right? All reals. It's not a system, just an equation. So we can plug in any number for x except the domain values. So x cannot be 0. And x cannot be, if you set that equal to, the denominator equal to 0 and solve, I believe you get negative 1/2. Okay, so now we have a situation here with x squared minus 15. So we're going to solve the equation. So we get, if we have trouble factoring, we can just put x squared equals 15. Square root both sides, don't forget, plus or minus. We get x equals plus or minus square root of 15. And this one, again, we want to kind of isolate that before we do anything. So we get x to the 4/3 power equals 16. Put both sides to the power of the reciprocal power, which is 3/4. Now notice we just took the 4th root, which is an even root of both sides. So don't forget to put plus or minus on one side here. So we're going to get, this is just x equals, I guess it'd be 16 plus or minus 16 to the 3/4. So now we've got to evaluate that. You could do that a couple different ways. You could think of the prime factorization as 16, not a prime number. So 2 and 4, 2 and 2. So we have 4 2's there, or 2 to the 4th. So if you think about it that way, that actually makes it pretty easy. So it'd be 2 to the 4th power to the power of 3/4. If you replace that. So you get plus or minus 4, that's 12/4 or 3, 2 to the 3rd, which is plus or minus 8, basically, would be our x value. Solve this one for r, just takes a couple steps. You can do this a couple different ways. You could divide by 1/3 h, A lot of students will multiply by 3 first. It just kind of makes sense to multiply by 3 to get rid of that fraction. So you get 3v equals pi r squared h. I guess we divide by pi h now. So you get r squared equals 3v. Don't worry about how messy it is over on the other side. We just need to solve this. So on both sides, you're going to take the square root of both sides. Don't forget to put plus or minus on the side you're not solving for. So we get r equals plus or minus the square root of 3v divided by pi h. A couple things about these literal equations. You never have to do plus or minus. So even though we're used to doing that, we don't have to, because these are real values. These are actual radius, height, volume of a cone or whatever this is of here. So we don't have to worry about plus or minus. Other thing is, I don't care how messy it is, just solve for the variable they want you to get for that. Solve the equation by factoring. So again, you can put it in the right order. We always like to order in order of degree. So I'm going to add 12 to both sides. Just try to factor it. It should factor nicely. Looks like 3 and 4. And plus and plus. And it does say solve. So to solve, you go to the next level, which is -3 set each factor equal to 0 and -4. So -3 and -4 are solutions. Here again, you want to set it equal to 0 before you do anything. So 10y squared minus y minus 3 equals 0. Try to factor that. So I'm going to try guess and check. We always do AC if we need it. I would start with 3 and 1. I know there's a y there, but I'm not sure what the coefficient. It could be, I'm not sure. It could be 5 and 2, 2 and 5. Just put 5 and 2. It could be 10 and 1 or 1 and 10, right? So I really don't know the answer here. So if I guess and check it, look at inside outside. I want to add up to -1. This is 15 and 2, no way. This would be, oh, this could work, right? So let's see, let's check this one out. So we've got, we want the bigger number to be negative because it adds to -1. So -3 and plus that one. Then you get set each factor equal to 0. If you do that, you get y equals positive 3/5. Set this equal to 0 and solve, you get -1/2 as your other solution for y. You can do it that way. The other way you could have done it is when you see AC, you could have done -30. Right, factor that as many ways as you can. 1 and 30, 2 and 15, 3 and 10, 4 doesn't go in there, 5, 5 and 6. Two factors that add up to make a -1. So I think that would be a -6 and a +5. So you've got it. You would take that middle term and split it up using these two terms. So it'd be like 10y squared plus 5x minus 6x minus 3. Then do factoring by grouping. You should get the same factoring and the same result. Solve by completing the square. This is kind of fun, right? Move the constant over, add it, so you get x squared minus 10x plus blank equals -14 plus blank. And to figure out what goes there, you can take half that middle term, which is 5. 5 squared is 25. And so this should factor super nice. So it should be x. There's a minus sign there. Square root of 25 is 5. And I guess that would be, let's see, 11. So then you're going to take the square root of both sides. Don't forget, plus or minus. And you get x minus 5 equals plus or minus square root of 11. Irrational answers x equals 5 plus or minus square root of 11 when you add 5 to both sides. Seems a little bit tougher, so we're going to move the 1 over first. We get 2x squared plus 12x equals a -1. You're going to divide everything by 2. This is a fraction over there. That happens. X squared plus 6x plus blank equals -1/2 plus blank. Half of 6 is 3. 3 squared is 9. So we add 9 to both sides. If you factor that, it should be really nice. X got to be plus. 9 is 3. It's got to be that. That's like 18 halves minus 1 half is 17 halves. And then we take the square root of both sides. So we get x plus 3 equals plus or minus square root of 17 halves. And so x equals negative 3 plus or minus square root of 17 halves. You could simplify that by multiplying by square root of 2 over square root of 2. So you get negative 3 plus or minus, I guess, square root of 34 all over 2 is your x value there. So set this equal to 0. So we're saying 0 equals 2x squared minus 5x plus 1. So it doesn't really give us a method, so we could choose whatever we want. Factors 2 that add to 5, I don't think it's going to factor, so I'm picking quadratic formula this time. Seems like a good choice. So that would be 5 over 2 times 2. So this is over 4. B squared is 25 minus 4 times 2 times 1. So we've got 5/4 plus or minus, let's see, 25 minus 8 is 17, so square root of 17 over 4. That would be the answer. You could write it all as one fraction, but that's the answer. This one, let's see, let's go ahead and try to complete the square. Let's see, factor 72 add to 6. 9 and 8 don't add to 6. I don't know. I'm just going to go complete square. Well, it might factor. Let's see, let's think. 70, so negative 72. Let's factor it a bunch of different ways and just see what happens. 1 and 72, no, that doesn't add. 2 and 36, no. 3 and 3 does go in there 24 times. No, 4 goes in there 18 times, I think. Still not there. We're getting closer though. 6 goes in there 12 times. Ooh, I like that. I like that a lot. Okay. So negative 6, so adds up to negative 6, so that'd be negative 12 and positive 6. So we found our factors. So we're going to split up that middle term. So it's going to be 8x squared. I like to put the negative first, just to, it's easier to do factoring by grouping, plus 6x minus 9. And so you can see that that's 4 terms. We're going to factor by grouping. Pull out the GCF. I guess that would be 4x times 2x minus 3 plus 3 times 2x minus 3. I like that. That means it does factor. So go ahead and regroup it. 2x minus 3 times 4x plus 3. Set each factor equals 0, so you get x equals 3 halves. So that you get x equals negative 3/4 when you set it equals 0. Solve it. And you got it. So this one, just do the discriminant. Remember, b squared minus 4ac. So b squared is 36 minus 4 times 1 times 9. Oh, wow. 36 minus 36 is 0. So when the discriminant is 0, there is one solution, one real solution. By the way, if the discriminant was positive, you would have 2 real solutions. If the discriminant was negative, you would have 0 real solutions, you'd have some imaginary solutions. So those are the three cases you have to know. Of course, in this case, when it's positive, if it's a perfect square, they're going to be rational solutions. If it's not, it's going to be irrational. Okay, so let's just evaluate, put it in the right form here. So that's subtracting. So I like to change the sign of the stuff in there. So 2 minus 4 is negative 2. Negative 7i minus 3i is minus 10i. And that's a plus bi form, so that works. FOIL it, we get 20 plus 12i minus 10i minus 6i squared. So this is really that's in the right form. Don't forget, pull out the I first. I times square root of 3 times I times square root of 8. So this would be I squared times square root of 24. That might simplify, right? So I squared is negative 1. So that's negative 1 times, let's see, factors of 24. So that'd be like 2 and 12, 2 and 6, 2 and 3. Don't really factor more. 2 with the 6 left over. So times 2 to the square root of 6. I would write it, oh wow, so just negative 2 root 6. Find all the solutions. Okay, if you can factor it, can't really factor that over the real numbers here. So let's go ahead and solve it. So x squared equals negative 9. If you subtract 9, divide by 25, get x squared equals negative 9 over 25. Take the square root of both sides. Don't forget, plus or minus. So x equals plus or minus, I guess that would be 3i over 5, or 3/5 I. And this one, find all solutions, the form of that. Factors of 20 to add to 5. I don't think so. So we're going to let's do quadratic formula here. So we've got x equals the opposite of 5 over 2 times a. So it's over 20. Be b squared, which is 25, minus 4 times 10 times 2. So that's going to be, if you kind of simplify just that part up there, sometimes I like to simplify that. That'll be 25 minus, let's see, what happens when I group those? 4 times 2 is 8, 8 times 10 is 80, so 25. So that's minus 25 minus 80, so 80 minus 25 is 5. That's 7 minus 2 is 5. So that's negative 55. Oops, negative 55. Okay, so then we're just going to simplify here. So this would be negative 5 over 20, or negative 1/4, plus or minus square root of negative 55, which is I root 55. And I don't think 11 times 5, I don't think that simplifies any, so that's a 1, by the way. I think you're done simplifying. X is that. Find all the real solutions. So factors of 2 that add up to 3. This might work, right? I think I can factor this, right? So in fact, let's challenge ourselves. So if I say find all the reals, you only have to, I think maybe I'll change your sheet so it doesn't say reals there. So I'm just going to change it so that it's all the solutions. So let's see if we can factor this. So I think we can. So it's 1 and 1. I know there's an x squared there. I know it's plus and plus. Really, the only thing I don't know is the coefficient of the x squared term. So it's either, well, it's got to be 2 and 1. And, it's got to be that if it works, right? Actually, maybe I do know. I guess double check. 1x squared plus 2x squared is 3x squared. 1 times 1 is 1. You got it. This works. Okay, so let's keep going here. So we can't really factor anymore over the real numbers. So I'm going to set x squared plus 1 equal to 0 and solve. And so I get x squared equals -1. Root both sides. Don't forget plus or minus. So x equals plus or minus I. So if this one equals 0, 2x squared plus 1 equals 0. So 2x squared equals -1. So x squared equals -1/2. Take the square root of both sides. Don't forget plus or minus. X equals I plus or minus I guess, root 1/2. You could probably simplify that a little bit if you wanted to. Multiply by square root of 2 over square root of 2. So you get plus or minus I times, this would be square root of 2 over, because that's underneath the radical, so over 2. I like that better. Or I guess you could write it plus or minus I root 2 all over 2. Be another way of writing it. Two cyclists start at the same time from opposite ends of the green line that's 45 miles long. They got 14 seconds ride, 16. So they want to meet. So there's two cyclists. Maybe one is faster than the other. I'm just going to draw it so they're not exactly the same length. The total distance there is 45, sorry. It's 45 miles. And then one cyclist riding at 14 miles per hour, then 16 miles per hour. Huh. So we've got, you got to figure out like what's the same, what's different. Think about distance, rate, and time. You might end up choosing like a, you know, is it like distance 1 plus distance 2 equals sometimes you can set two things equal to each other. It does look like the times are the same, so maybe maybe you can set up the times and do that. So times the first guy and times the second guy is the same. I think I'm going to try this. So this I like the formula dirt distance equals rate times time. So let's see how this works. So this will be distance 1 is rate times time. So let's do 14t. That's distance 1. Distance 2 is rate times time. So that'd be 16. It's the same time, so it's the same t, right? I think it is. Equals total distance, which is 45. So 16, 14, that's 30t equals 45. Kind of like that. Divided by 30. Time equals 1.5. I think that's miles per hour. So how long after they travel would they meet? 1.5 hours. So it can all quarters and dimes. All quarters and dimes. So you can set up your equation. 0.25 q plus 0.1 d equals 9.60. Your other equation would just be, something like p plus q equals 63 coins, right? So now you've got to, figure out if you can use substitution or elimination or what you're going to do. So you might think about, let's see, if we multiplied, I love to get the exact opposite. So like for q, for example, if we wanted the exact opposite, we can multiply everything by 10 to get 1d there. Why, why do you use P and Q? I don't really know. I don't know. So let's use the same variables we used a minute ago. It's kind of funny. So quarters and dimes, so I'm going to use Q plus D. That would kind of work better. Okay, so you want to get the D's to be the exact same or exact opposite. If we multiply by 10, they be the exact same. I thought try negative 10 because I think this will help things a lot. In fact, ooh, but it still gets a little fraction there. So this would be negative 2.5 Q minus 1 D equals negative 96.0 or 96. So we can now kind of line up the equations. I'm going to move this over here. So Q, I like elimination a little better. Plus D equals 63. So this is like, if you add them, that's going to be negative 1.5 Q equals, let's see, negative 33. You might want to write this as a fraction. This might be easier. Negative 3 over 2 times Q equals negative 33. So if I multiply both sides by the reciprocal of that guy, so multiply by negative 2/3, multiply by negative 2/3, and so you get Q equals, and the 3's cancel there, you get negative 11 and 1 there, so you get positive 22. I'm glad I got a positive number. You have 22 quarters. If they add up to that, so minus 22, this would be 41, and we have 41 dimes. You can always work that out, make sure it works. So the nonlinear equality express your answer in interval form. So this is like squiggly line kind of stuff. So your two solutions there, if you set each factor equal to 0, that would be 2. It's one of the numbers on the line, and negative 3. So when you're testing numbers here, just test a number in each interval here. So something bigger than 2, something in the interval on the right there. So I don't know, 10. 2 minus 10 is negative. 2 plus, or 10 plus 3 is positive. Squared is definitely positive. So negative times a positive is negative. So that starts out negative. In the middle, plug in 0. So 2 minus 0 is 0. 0 plus 3 is 2 minus 0 is positive. Sorry. And then 0 plus 3 is positive. So and squared is still positive. So positive times positive is positive. And plug in a number smaller than negative 3. How about negative 10? So 2 minus negative 10 is positive. Negative 10 plus 3 is negative, but squared is going to be positive. So that's also going to be positive. This is kind of a weird one, right? It's going to start low. It's going to kind of go through. It's got a touch here, but it doesn't have to go through. It stays positive, evidently, so it's going to kind of bounce off that point. If you remember the idea of multiplicity, this is to the second power, so it makes a lot of sense that actually right there, it bounces off the axis right there, and whereas this is to the first power, which is odd, so it's going to go right through that axis right there. I want to find the graph when it's less than or equal to 0. So where is it, below the line or on the line? So what's interesting is that's all below the line or on the line. And there's this one little point right there that makes sense that is also on the line. So your final answer would be something like x is bigger than or equal to 2, comma, x is also equal to negative 3. Something like that would work. You're basically saying it's the interval, where that interval off to the right, and also the one point that is on the line, because it can be equal. There's a little equal sign right there, and that means it can be equal to that value. Solve the inequality, express the solution in interval notation. So you can break this apart to get the positive and negative case. X plus 2 is less than 1, so x is less than negative 1. So that looks something like this. Less than, so I'm looking for and, the overlap of these two. So negative x plus 2 is less than 1. So negative x minus 2 is less than 1. Negative x is less than 3. X is greater than negative 3 when you divide by negative. So that one looks something like this. Uh-oh. And less than, this is not going to work, is it? So there's no solution to this one. So there's no overlap. So there's no solution. Wow, it's interesting. See why. So it's saying the absolute value of those two things, x plus 2 is less than 1. Negative x minus 2, just double checking my work here. Okay, so you got to pay attention to the negatives here. So this is not actually the graph of that. I had it written correctly. I guess wasn't paying attention. So x is greater than or greater than negative 3. So negative 3 is right down here. Greater than would look like this. So the shading, the overlapping region, the solution is actually open circle there, and everywhere in between. So from negative 3 to negative 1. But that would have been a lot faster using the shortcut. Let's just look at that, see if that would have been easier. So using the shortcut, you can get rid of the absolute value bars. If you put the other side, you put negative 1. Whatever's on the right, you put on the left and just make it negative. So then if I add 2 to, or subtract 2 to both sides here, to all sides, I guess, you get negative 3 less than x less than negative 1. Yeah, that's faster. Same answer, a lot faster. So with the and statements, you can use that shortcut if you want. This one, so it's ready to break up, right? 2x minus 1 greater than or equal to 4. So 2x greater than or equal to 5. So x greater than or equal to 5 halves, which is like 2.5, so something like this. The negative case, I'm going to get over here so I have more room, is negative 2x minus, that'd be plus 1 greater than or equal to 4. Subtract 1, negative 2x greater than or equal to 3 divided by negative 2. So x is greater than or equal to negative 3 halves. Negative 3 halves is like negative 1.5, so x is greater than or equal to negative 1.5, something like this. This is a Gray-Tor statement, so it's an OR statement. So or either one of these are true, so either one can be true. So the final answer is this. It would be x greater than or equal to negative 3 halves. Or you could say from negative 3 halves to infinity in the other notation. And it'd be a bracket right there, wouldn't it? Because that's a closed circle.